binary or binomial logistic regression with the binary or dichotomous predictor in STATA. Binary variable is the variable that have two levels in it. So binomial or binary variable is the variable that have two levels in it, such as dead or life, have diabetes or doesn't have a diabetes, heart diseases, have heart diseases, yes or no. So the binary means two levels. Logistic regression is a statistical method that can be performed when there are two variables. One of the variable is called the outcome, or the dependent variable, or the response, and this response or outcome is binary or binomial, which means there are two levels in it. So the outcomes has to have two levels in it to do binomial logistic regression, and the other variable, which is called the independent variable, or the exposure, or the explanatory variable, or the predictor. The predictor can be a continuous variable, can be a binary predictor, can be a categorical predictor, or an ordinal predictor. So logistic regression, one of the conditions to perform binary logistic regression, or the assumption, is that the outcome has to have two levels in it, and the predictor can be any type of data. Here we will look at how to find out whether there is an association between a predictor that is binary and an outcome that also is a binary, that has two levels in it. So aims of logistic regression is to find whether there is an association, or the predictor can contribute to the outcome or have an effect on the outcome. Here in this STATA view, I have two variables. The most important one, which is the heart disease, which is the outcome. So it has two levels in it, yes or no, whether you have the disease or you don't have the disease. So this is a binary or binomial variable. And the other variable, which is the independent variable or the predictor, is the sex, which is the gender of individual, whether it can be a male or a female. So this variable again is binary or binomial. To find out whether the outcome is associated with the gender and whether the females have a higher chances of having heart diseases compared to males, or the males have a higher, then the binary logistic regression will be performed as the outcome is binary and the predictor is also binary, which is the sex. To do the logistic regression, here in the command section, let's look at the data, examine it, and determine the frequencies. So type tab and then insert the outcome and type the outcome here, which is the heart disease, space, and then the predictor, which is the sex, and then comma, and then type call for column and hit enter. A 2x2 table is generated as shown here. On the left hand is the heart diseases, yes or no, and the sex, female and male. And the part we are interested in is the yes. And we can see here that there are 58.3% of males that have heart diseases and 28.85 females that have heart diseases. So whether the females or males are associated are more likely to have heart diseases, then the logistic regression will be used, or in fact specifically the binary logistic regression. And to do that in STATA, in the command section, type logistic space, then type the outcome, which is heart diseases, space, then the predictor, which is the 6, hit enter. A table is generated in STATA view, and as shown here. And to interpret and analyze the data, 2 important values to look at, in fact 3: the odd ratio, the p-value, and the 95% confidence interval. Looking up here, the number of observation is 100, as we have as shown here, 52 females and 48 males. So the total number is 100 participants. And the odd ratio here for the 6 is 3.45. In logistic regression for the 6, the females have a value of 0 and the male is given a value of 1. So the females are used here as a reference category. So the comparison here is to the reference category, which is the females. So this data means that the males have a higher odd ratio. So males are 3.45 times more likely to get heart diseases compared to females, or it's read again as the males odd ratio is higher, 3.45 than the females, and the p-value is less than 0.05. So this is a significant relationship. So this p-value is significant, and these findings are significant. So there is a significant difference between males and females, and males are more associated with having heart diseases. And if we look at the 95% confidence interval, which adds another layer of statistical significance, the odd ratio is 3.45, which is between the upper and the lower values, 1.5 for lower, 7.9 for upper. So this confidence interval, upper and lower value, does not include value of or a value of 1. Then this also confirmed that the observation is statistically significant, and the males have a higher odd of getting heart diseases. Or in another way, it can be read as males have 245% higher chances of getting heart diseases compared to females. So this is the way to do binary logistic regression with dichotomous or binary predictor in STATA.